So we've solved systems of equations that had two equations and two unknowns. Now we're going to look at when I have three equations and three unknown values. Alright, so make sure you need to follow on very detailed notes here. So follow along, make sure you pause if you don't understand, rewind if you need to see something again. This is very detailed. Make sure you take very good notes. Alright, so just like with a 2x2 system, 3x3 systems can have no solution, and that's when the three planes that we're looking at have no points in common. One solution means that they're going to intersect and we're going to get a ordered triple as our answer, or infinitely many solutions whenever they overlap in a common line. Alright, so we will not be solving these by graphing. We're going to use elimination and substitution. Now again, with 3x3 systems, you really need to just use your math intuition and to decide which method is going to be best. Okay, so I'm going to show some examples using both methods. Now, whenever you get your answer should always be an ordered triple x, y, z. Alright, so step number one is pairing up the equations. Now, I need to use each equation at least once, and one of the equations I'm going to use twice. Now, when we want to pair up, we want to take a look and decide which variable do I want to get rid of first. Now, in this particular problem, I'm going to say I'm going to get rid of z. Now, that's going to change from problem to problem. You just have to have a little bit of math intuition and decide what's going to be easiest for you. Now, pairing up the equations, I'm going to pair up the first and second, and then I'm going to pair up the second and third. So notice that I'm going to use 2 twice, and each one will be used at least once. So now when I pair up, I need to make sure that I eliminate the same variable in each pair up. So 2x plus x gives me 3x. Negative y plus 3y gives me positive 2y. Plus z minus z is 0, and then 4 plus 11 is 15. Now this equation is going to be important, so I'm going to go ahead and box it. I like to do this so I don't lose it in all my work. Now with the second pair up, I'm going to do equation number 2 and equation number 3. So again, you need to eliminate the same variable. Now right now, both of my z's are negative. So I need to do something to make one of them positive. So I'm going to go ahead and multiply the bottom one by negative 1. So my new equation is x plus 3y minus z equals 11, and negative 4x minus y plus z equals negative 14. So now I'm going to draw my big equation, and I'm going to add. So x minus 4x gives me negative 3x. 3y minus y gives me 2y. And then negative x plus z is going to give me 0. And then 11 minus 14 is a negative 3. So this is the other equation that's going to be very important to me. So I'm going to go ahead and box this. And then I'm going to move on to step number 2. Alright, so what we do next is we create a system from the two equations that we just found in the first step. Okay, now when we do this, you want to solve this just like you normally have. This should look like a problem that you've seen over and over and over again, okay? So, we're going to do some more elimination. You decide which variable you want to eliminate. Here it looks like x is going to be easier to eliminate, so I'm going to eliminate x. So eliminating x, I get 4y equals 12, so y is going to be 3. I'm going to go ahead and box this. This is an important guy. Now that I know one of the variables, we do this just like we have been. You take this guy and you plug it into one of these equations. So I'm going to get negative 3x plus 2 times 3 equals negative 3. So negative 3x plus 6 equals negative 3. Negative 3x equals negative 9. So x is going to be a positive 3. So I know x is 3 and y is 3. Now I have two of my unknowns, and I'm going to move on to the next step. So in my last step, I solved and I found that x was 3 and y is 3. So the last thing I need to do is find z. So I'm going to take my values I just solved for and I'm going to plug them into one of the original equations. So I'm going to do 2 times 3. I'm going to use equation number 1 here. 2 times 3 minus 3 plus z equals 4. So 6 minus 3 plus z equals 4. So z is going to be 1, okay? So fantastic. I've found all of my 3 unknowns, and I'm going to write my solution as an ordered triple. That was 3, 3, 1. That's x, y, z. And now what you should, of course, do is take what we just found and plug it into each of the equations to make sure that we solved it correctly. It has to work for all 3. So we can also use substitution. Now, we don't always want to use substitution, but we want to use it whenever it's most convenient. Well, in this particular type of system, I have a system that's a 3 equation, 3 unknowns, and this one has all 3. This one only has x and y, and this one has z and x. So it's a little weird. They don't all have all 3 unknowns. So what I'm going to do is first choose the equation that looks like it's going to be the easiest to solve for a variable. Well, in this case, that's going to be number 2 because x is all by itself. So I'm going to go ahead and solve for x. X is going to be negative 5y plus 9. All right, so now that x equals negative 5y plus 9, I'm going to take this and plug it into the other 2 equations. This is going to leave me with a 2 by 2 system that I can solve. So plugging it into the first equation, I get 2 times negative 5y plus 9 plus 3y minus 2z equals negative 1. I like to cross my z's to make sure they don't get confused with 2's. So negative 10y plus 18 plus 3y minus 2z equals negative 1. Combine like terms. I get a negative 7y minus 2z. I'm going to bring the 18 to the other side, so I'm going to get negative 19. So this guy is going to be important. I'm going to go ahead and box him. Now, I need to plug in the value I found for x, so this, into the other equation, okay? So now I'm going to do that. I'm going to get 4z minus 5 times negative 5y plus 9 equals 4. Okay, distributing. I get 4z plus 25y minus 45 equals 4. Combining like terms, I'm going to get, and I'm going to rewrite it, 25y plus 4z equals 49. Okay, so I just combined like terms there, and then I moved it around so that these guys will line up. So now I have a 2 by 2 system, same variables that are missing, and now I can solve this like I normally do. Alright, so I need to solve this system. Well, it looks like it's going to be easiest to eliminate z, but in order to do that, I need to multiply the bottom by 2. So I'm going to be left with negative 14y minus 4z equals negative 19 times 2. And then I'm going to have 25y plus 4z equals 49. Here's my new system. And I'm going to do my big addition problem. And that's going to give me 11y equals 11. So y is going to be 1. Yay, I found one of the variables. So now I'm going to take the variable that I know and I'm going to plug it in to one of these equations. Doesn't matter, but I plug it into one of these. So let's plug it into the first one. So 25 times 1 plus 4z equals 49. So bringing the 25 over, 4z equals 49 minus 25, which is 24. So z is going to be 6. So yay, now I know z equals 6. So now I'm going to take z and y, and I'm going to plug it into one of my original equations. So one of these guys, okay? Now I just want x. So actually I could plug into this one if I wanted. I could plug into this one. I can plug into any of them. It's whichever one's going to take the least amount of work, which I think is plugging into equation 2. So I'm going to have x plus 5 times y, which we found was 1, equals 9. So x is going to equal 4. So now I know all three values, and I write my ordered triple. 4, 1, 6. And yes, they have to be in order, x, y, z. Now I would take this ordered triple, and I would plug it into each equation, and I would make sure it works for all three. Go ahead and give these a try.